Multiplying and dividing, simplifying rational expressions. Today, we're going to look at adding and subtracting. Adding, just like with regular fractions, adding and subtracting rational expressions is a little bit more cumbersome than multiplying and dividing because you got to get a common denominator, right? So how does this work? Just like with regular fractions, if I add up two fractions, and this is all review, if I add two fractions with common denominators, what do? We write it as a single fraction with our common denominator, and we just add the numerators or subtract the numerators of the individual fractions in a single numerator, right? So you're used to that. Like, what, for example, if I were adding or subtracting these fractions here, what would the result be? What would I do? Like, what if you were adding, let's just look at numbers. Like, what if you were adding, or doing this? How about if we had, what's 5 sevenths minus 3 sevenths?
2 sevens.
2 sevenths, right? I have common denominator. So I just get 5 minus 3 over my common denominator, which is 2 sevenths, right? So what am I going to do here?
36x squared over x.
Okay, so I got a common denominator. So I can write this as a single fraction. X squared minus 36 all over x plus 6. Okay, so we're done with the subtraction part. Now, what could I do with that rational expression from yesterday? Good. Okay, factor the top. Bottom is already factored. Factor the top. Factors into x plus 6 times x minus 6. And then I would cancel the x plus 6's, right? But what do I have to remember on this one, too?
It's only multiplication.
Bottom can't equal 0.
The bottom can't equal 0. So what's the value I have to exclude from the domain?
Negative 6.
-6. There you go. Okay. And we'll write that here. X cannot equal -6. Now we have to write that down before canceling because once I cancel, we wouldn't know that, right? It just looks like a normal function, x minus 6. So before canceling, you got to write down your exclusions. Okay. What's wrong with this one? I see this a lot. I've seen this stuff like this already this year a little bit. Very common mistake. Spot the error there. What's going on? Parentheses around what?
Oh, they do turn the last three to negative.
Okay, right. So I'm actually, what I'm really doing here, if we include parentheses might be useful, right? We've really got this numerator minus that numerator. Agreed? So we don't really need the first parentheses because they're not really accomplishing anything. Nothing's being distributed, but I definitely, thank you. Happy birthday, by the way. I definitely need the second ones because I'm subtracting the whole thing, right? The first ones are kind of optional. So I would have to distribute that negative to both parts, right? Very common mistake when you're subtracting fractions. Remember, you're subtracting the entire quantity that's in the numerator. So always make sure you put that in parentheses. Okay, so let's have a look here. How about one like this guy? Why don't you guys quickly just go try this at the boards? Simplify.
Can we erase the advisory?
Yeah. Erase everything. That's fine. Go ahead and erase anything that's up there. Okay, what do we got here? Okay, good. Right, first step. Okay, so we're going to distribute that negative, and that's going to give us n squared plus 3n minus 7 minus n minus 1. There's everything in the numerator. So we get n squared, what do we end up? Plus 2n minus 8 over n squared plus n minus 6. So there's the subtraction's done. We got it subtracted. Now we just have to simplify that, right? So we factor the top. What are my magic numbers on top?
Positive 4, negative.
Good, positive 4, negative 2. On the bottom, magic numbers, plus 3 minus 2. Okay, so what are my exclusions then?
Negative 3.
Negative 3, positive 2. We can cancel those guys, and that's our answer, right? Make sense? So we just get, there's our simplified answer. Okay, give me thumbs. All good? Look good. All right. Okay, so now what happens when we're adding and subtracting rational expressions where we have to have a common denominator? So here are the steps. We're going to rewrite the problem using a common denominator, and then we're just going to, like always, combine the numerators and keep the denominator as our common denominator and simplify. The only additional step is that step 1, but that's kind of a big one. We got to rewrite the problem using a common denominator. So how do we find the least common denominator? We have to just factor each denominator completely, and then we're just going to compile a list of all. That's going to be we're going to have a product of all of the unique factors that show up, but we have to make sure that we raise the power of each factor to the greatest number of times that factor appears. So for example, if I have something like x plus 1 squared in one denominator and x plus 1 to the first power in the separate denominator, I keep x plus 1 squared. I have to keep the greatest power that shows up of each factor in the denominator. So let's practice this. Okay, so real quick, just review what we just said. The least common denominator of two fractions is the what? Well, it's going to be the product. We're going to multiply together all the different what? That show up in the denominators. Factors, yeah. All the different factors from each denominator, with each factor raised to the greatest power that occurs in any factor, or in any of the individual denominators, sorry. Okay, so let's find a couple of these. Let's try this one. Find the least common denominator of these rational expressions. So what would we have to do first? What do we have to do to those denominators? Okay, factor them, which is going to involve factoring out a GCF. So this first one is going to become, what's this guy going to be?
5.
So we're going to get 9 over, we could factor out a 5, and then we're left with x plus 3. Right? How about the next one? If we factor this guy, we factor out a 7, and we're left with x minus 2. So what's our LCD going to be then? Well, we have to have each factor that shows up. So we're going to have a 5 that shows up. We've got, let's do the numbers first, the constants. We've got a 7. We've got an x plus 3. And we've got an x minus 2. Now, we could combine the numbers. That's fine. So we could rewrite that as 35 x plus 3 times x minus 2, but we'll leave it factored. That's our LCD. Okay. How about those? Let's just make a list of all the factors that show up. What's going to show up in that denominator?
X minus 4, x plus 4.
Okay, x minus 4, x plus 4. Here we've got an x. Here, what are we going to get from this one?
Take out 5.
Okay, we take out a 5. And what's left behind? Okay, so then if we want to write our LCD, what's it going to be? So we got an x minus 4. Let's do the number first. So we got a 5. We've got an x minus 4, x plus 4. let's put the monomial first. There's the x. Do we need to add a 4 minus x? We don't. We don't, because 4 minus x and x minus 4 only differ by negative 1, right? So when you see that, you don't have to write it separately. It just means that what we might want to do when we're adding these fractions up, we might want to multiply this one by negative 1 over negative 1 to make that factor look the same in the denominator. Does that make sense? Okay. We'll look at something like that. So that would be our LCD. Okay, how about this one? Why don't you guys go try this one? And then the boards try that. Okay, so let's look here. Let's kind of color code these.
When you give us back to me, she's not gonna video of him vacuuming.
So that's our red denominator. What are the factors of the red denominator?
4 times x minus 1.
Okay, good. So there's the red denominator. Okay, this is going to be our blue denominator. That's not blue. What are the factors of our blue denominator?
Plus 3 x minus 1.
Okay. And then how about the green one?
X plus 3, x plus 3.
Okay, x plus 3. So the magic numbers would be 3 and 3, right? So x plus 3 times x plus 3 is x plus 3 squared. Okay, so now if we want to compile our LCD, we're just going to go through, and any new denominator that shows up will add to our LCD. So we start off, we need the 4 and the x minus 1, right? Okay, well, we look at the next denominator. Okay, x plus 3 is a new factor. We need that. X minus 1, we've already got. Okay, so we don't need to add that one. What about the green one? X plus 3 we've got, but it's being squared, so we would need to square it because it shows up twice. Does that make sense? Another way to think about that is one of those x plus 3s is already accounted for, but now we got another one, so we have to include it. Okay? Give me a thumbs. Does that all make sense? Okay. All right, so now let's put this into practice. Let's actually go through this process. Here's a simpler way of this is from our textbook, but this is kind of a simpler way of thinking of it, right? Rewrite the problem using common denominators, combine the numerators, keep the denominators common, and then simplify. So let's look at an example like this, okay? So what do we do then? Okay, to get there, what's the first thing I have to do? Factor, yeah. Now, I do not need, okay, there's a temptation. Sometimes people want to try to, and I can't really factor anything here on the top. People sometimes want to factor the numerators. Should I do that? No, don't do that, because we're going to end up adding and subtracting a bunch of stuff in the numerator, which is going to change it anyway, right? So we're not going to factor the numerator until we've already added or subtracted all these fractions. Then we'll simplify everything by factoring the numerator. But don't bother with that initially. We do need to factor denominators though. Okay, so this first one is going to factor into what on the bottom? I've got my x squared minus 5 on the top. What do I get on the bottom?
X plus 2.
X plus 3 times x plus 2, okay? Plus 1 over x plus 2. Okay, I need to get a common denominator on the bottom. What's that going to be? X plus 3 times x plus 2. So to get that, what would I have to do to my second fraction to get that common denominator? Okay, good. I'm going to multiply by 1, right? So I'm not changing anything. 1 is the multiplicative identity. Multiplying by 1 preserves the identity of whatever I started with. So I'm going to take this second fraction, and I don't want to change its value. I just want to change its look, right? So I'm going to multiply by x plus 3 divided by x plus 3. And now I've got a common denominator, right? Okay, so then we get our common denominator, x plus 3 times x plus 2. And what do we get? Well, we get this thing, right? We get all that stuff, x squared minus 5 plus, there's my plus sign, plus all that stuff, 1 times x plus 3. Okay. Now, technically, I probably need to have the parentheses, but because I'm adding, they don't really do anything, right? So even though I'm adding this whole quantity, x plus 3, we could just turn right around and maybe subtract those parentheses. We don't need them. If we were subtracting, we've got to have them, right? Because then I have to distribute the negative side. But when we're adding, really, we're just adding polynomials in the top, right? When I add this polynomial, I'm just adding like terms. You don't need parentheses when you're adding polynomials, only when you're subtracting, right? Okay, now what do you think we do? Combine like terms. So we get x squared plus x minus 2 over the bottom that's already factored. What does the top factor into?
X minus 1, x minus 1. Oh, x minus 1 squared.
Sure.
That's
Wait,
x
oh,
minus
really?
2.
X minus 1, x plus 2.
Oh.
Okay, so we're about to cancel. What do we have to do before we cancel, though?
Take out the
Exclusions, yes. What are we excluding from our domain here? Good, x cannot equal -3 or -2. Now we can cancel those guys and we get our final simplified answer. It's just x minus 1 over x plus 3. And we don't need parentheses anymore, right? Because now there's nothing other than just those single factors, the numerator and denominator. Okay? Give me thumbs. Does that make sense? Okay. All right. Why don't you guys go try one? All right, first step, we want to factor denominators, right? So the first denominator, everybody got that factored. I just take out a 2. I get 2 times the quantity r plus 4. I'm going to leave a big space here. Minus 8 over, I can factor an r out, and I get r times the quantity r plus 4. Okay, so I need a common denominator, right? Are there any factors in the second denominator that I don't have in the first one? R, right? I'm missing the R.
Oh, wait, I was backwards.
Yeah, backwards. Right. Anyway, so R. So I'm going to multiply this guy times R over R. So I get that R in the denominator. I need it. Any unique factor that shows up in a denominator has to occur in my common denominator, right? So now we go to the next one. Are there any factors I'm missing in my second denominator that show up in the first one? 2. Okay, so in order to get the same denominator, common denominator, I'm going to have to multiply this guy by 2 over 2. Right, and so now I've got the same denominators. Right, so what do we end up with then? So up here we've got r squared minus 8 times 2 is 16 over my common denominator of 2, I'd probably put it in this order, right? Constant first, then monomial, then binomial. Make sense? So what are my exclusions?
-4 and 0.
-4 and 0. Good. There you go. What's left to do? Factor the top. Yep. Good. So we get r minus 4 times r plus 4 over 2r times r plus 4. And we can cancel those guys, right? And then we get our answer. R minus 4 over 2r. Okay, good? All right, so you can jump in and do the assignment. I did something a little different with the assignment. Don't throw stuff at me. I broke it into 2 parts. First part, about half and half. First part, you have access to all the, like, help me solve this and do an example. Second part, you do not. Okay, so it's just equal, they're both pretty short. All right.
I want you to